Okay, we're good.
Okay. All right. So for number 3, because the first 2 are gimmies, for number 3, the symbol of the true population proportion is
Regular P.
yes. And for 4, when I worked this out here as I went through it, it is true, I think.
That's what I got. Where's my calculator? You think it's rude if I don't talk to her?
It's not entirely her fault.
Yeah, but still.
It's partially her fault.
Hmm. Okay, so the requirement.
And 5 is true because when you punch the numbers into that Excel spreadsheet, it actually tells you that, effectively, yes, they're all greater than 10.
Yeah. So 4 and 5 are true.
Yep.
Okay.
And for 6, the silly P, as I call it, or P hat, as they call it, point estimate of the proportion of the first-degree murder defendants found guilty in the state, I put it as 0.750.
Which equation plug that into?
Why do you think it's 0.750?
Well, because it should be 45 divided by 60. 0.750.
Correct.
So margin.
Now, I screwed this one up, the margin of error.
Mm-hmm.
So I had to go dig around and try to find my list of formulas here so that I could try to figure this out.
The margin of error for this one
That's the big equation.
Z times the standard deviation.
Right.
So we probably have to find the Z-score.
And the standard deviation.
Right. Well, the standard deviation's easy because we know the equation, right? So
yep.
If P is... Oh, but it's different. They're different numbers now.
Okay, so the standard deviation is... Do we want it of the hypothesis test or a confidence interval?
Confidence interval.
Then it's 0.056.
Why?
Because I punched it into that nifty spreadsheet.
With the Excel one?
Yeah.
Wait, what did you...
This time we're supposed to use it.
Yeah. Yeah, I know. Wait, where did you put it?
So what you do is on the green squares on the left where it says inputs, X is 45.
X1?
I'm sorry?
Because it has X1, N1, X2, and N2.
You're on the wrong one. You want to go to the tab for...
Oh, the one proportion. Yep, that's right.
So X would be 45. And then N is 60.
But what did you put for the null hypothesis? Just 0?
Well, nah, you know what? I didn't think about that. It didn't say to touch it, so I didn't. Because in the reading it said don't bother. You only work with the top 2 fields. Let me go back, leave the reading again.
Oh yeah, I guess that only matters for the p-score. Or the p-value. Okay. 0.056.
Okay, so
So for standard deviation, 0.057. Oh, but we can't round, so never mind. And I know why we got 15 wrong on the last quiz.
yeah, how was that?
Because for 15, it's technically right, but the calculation was wrong. You can't use the rounded standard deviation, which is what we were doing. You have to use the not rounded standard deviation.
Good to know.
Yeah.
Wait, what do you mean by that? Sorry. So if it's like 0.0677, we don't round it out?
Not until you're completely done with your calculations.
I think I get what you're saying.
Okay, so like for this one, if we're finding the margin of error, you know how it's z times the square root of the standard deviation?
Yeah.
So if the standard deviation is 0.0568, you have to keep that number. You can't say 0.057.
That's
So like the standard deviation for this is 0.0559 is what the spreadsheet shows. It only goes out to 4 digits.
What are you looking at?
The one sample z-test for proportion.
Mine says 0.0568.
And you've got x is 45, n is 60.
I do now.
Okay, had me worried there.
Okay, what is your standard deviation?
The standard deviation for confidence interval I'm showing is 0.0559.
Okay, just making sure. Jordan, are you following?
Yeah, I'm trying to do this on my calculator. I don't want to use Excel throws me off a little.
How do you find the z-score again? I can't find my notes.
Oh, the z-score?
Yeah.
It's on the spreadsheet as well.
What?
It's in the cell marked Z.
Well, maybe I should actually look at the spreadsheet. Okay,
Yeah,
so then
once
the
I-
margin of error is easy. Then
Yeah.
it's just 0.845 times the square root of 0.0559. Which gives us 0.19. Oh, I guess it would be 100. Is that what you got?
Hold on, what, you got what?
Well, it's 0.1997. So the 7 rounds the 9 to 0.
Wait a minute, that's not what I got at all. Let me go back through this. Divided by... Yeah, I'm not getting that. 0.007? Huh?
No. Hang on, I'm doing it again just to make sure. Yeah, 0.1997. 84878. Is that what you got?
No, not even close either time I tried it here.
Okay, you're doing 0.845 times the square root of 0.0559,
No.
right?
Well, no, because it's the square. It's the sample. Sorry, we're looking for margin of error, right?
Yeah.
So the margin of error is z times the standard deviation divided by the square root of the sample size. Our samples, yeah, it's what the formula I'm showing here is the square root of n. It's standard deviation over the square root of n multiplied by z.
Yeah.
Okay. So the square root of p times 1 minus p all over n, that's the formula for the standard deviation. So you're just multiplying z by the standard deviation. Does that make sense?
Hold on, I'm going to look. Where are you seeing this at?
It's from the last lesson.
Right. How did I get this? Why does one? Yeah, the formula I'm showing is a different formula.
Okay, hang on. I could be wrong, but I don't.
No, you're right. I'm looking at this week's lesson, and that's a completely contradictory than what the last one was.
I can move down.
I think because they're just showing a different way to find the margin error for this lesson.
Yeah, but it doesn't come out the same, so it's not a different way. It's a completely different equation. So, okay. Let me mark out what I've done here and start it again just to make sure I'm understanding here. So it was 0.8 times the square root of
0.0559.
Okay. .19978.
Yep.
Okay.
But it rounds to 0.1.
No, it would round to 2. It's 0.199 or 1997. So
Yeah, so it would round to 1.1. I mean 1.2. Right?
how would it would be if it's 0.199 or 1997. This 9 is going to round to 0, which is going to round to the next one over is going to round to 0, which is going to put it at 2.2. Or am I way off? I'm not good with rounding. I'll be the first one to say it.
Yeah, would it just be 0.200?
0. Yeah, exactly. That's what I'm saying.
Oh.
You with us, Jordan? Making sense?
Kinda. I've been doing a project for the last 5 hours. I'm a little slow right now, but I'm trying to figure it out.
What? Hey, I'm sorry. Did I miss something? What did we get for? Oh crap! I put that in the wrong place. All right, my thing keeps bouncing around every time I leave the screen to go to the calculator. So we're on number 7 still, right?
We just did number 7.
That's okay. So let me go back and find where I just keyed that answer in, because it went into the wrong place.
Yeah, I've moved down to like 11 and 10, 12, trying to. I wasn't getting those.
So 8 then is going to be 0.640.
No, because
It is
our null
according-
hypothesis is not 0.70.
So what is our null hypothesis then?
I don't know, but it's not 0.70.
Let's go look at the reading for the week here. I'm not sure where we get that null hypothesis from. Let me go back and look at these numbers.
20.
Well, you know what? I don't think it matters because I just changed that null hypothesis from 0.70 to 0.60, and it did not change the confidence interval. Nor did it change the p hat. However, it did change the p-value and it looks like the z-value.
Okay.
I mean, I don't know because the reading doesn't tell us anything about the null hypothesis, and I don't understand what they want us to calculate then.
Okay, so 10, if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
For 10, I'm showing it's going to decrease. But I'm not sure if I did that right. Hold on.
Well, you would just have to change n to 80.
Right, no, but I think I might have written the numbers down wrong.
Did you just say Roten?
Yeah, it's been one of those days. We're still dealing with that hospital issue, so that's where my day has been.
Hey,
0.45.
Sarah,
Huh.
can I take you down to number 14 real quick?
Yeah.
Is that 0.475?
It would just be whatever 38 divided by 80 is.
Yeah.
0.475, right?
Yeah, okay, so then on 11 and 12, is it 20 and 100?
For what? Sorry?
11 is it 20 and 12 is 100?
That's kind of what I thought, because if you remember, 1/4 was 40.
Yeah.
Oh, I think I wrote down how to do this. Hang on.
No, I mean, they're pretty easy. I just want to make sure I have them right before I keep moving on that.
No, I'm with you, Jordan, because I was guessing based on what we did last time.
Yeah, I was just a little confused because this feels like last chapter, not this chapter.
Yeah.
And I was like, why are they asking these questions? Am I missing something? Keyboard's so dusty.
Okay, you guys, I was right. On 7, it is 0.11.
On 7?
Yep, because the 1 doesn't round. The 9's round to 1. It's 0.11. Because to double check it, you take the upper confidence interval minus the lower confidence interval divided by 2, which is 0.11.
That's 2 decimal. But okay.
So would it be 0.110?
Yeah.
Okay. So we're back down to 11.
I'm on 13.
Okay, 12. So 11 was 20. 12 was 100. 13. Okay. X is 13.
Okay.
So yes, the hypothesis test is satisfied, right? It's more than 10.
Yeah.
Yeah, it was 15 that I screwed up and put the answer to 7 in.
Is that a Mountain Dew I hear?
Mm-hmm. It is indeed. It's diet. It's all right?
Oh, yeah.
The one before it wasn't, but that's okay.
Okay, so 14, what is P? Did we already do 14? You guys
Yeah,
didn't
it should be like 0.475, right? Because it's just 38 divided by 80.
Oh, yeah, that's right. Sorry. And then the test statistic.
That was where I was kind of drawing a blank.
Okay, let me look.
And the spreadsheet does not show test statistic, I looked.
Right. Okay.
Although I am concerned now that I look at the p-value, because it shows it as 0.000.
What?
In the spreadsheet, when you punch this stuff in, it shows it as 0.000.
That's okay, that's happened before.
Yeah, I always get leery when something's that simple and small. Especially since I don't quite grasp the null hypothesis as to why that's 0.70.
Hey,
Well, for this one, the null hypothesis is 0.60.
Ah, good point.
Sarah, can I ask you about number 15?
Yeah, hang on.
All right, so that
Yeah,
puts
I'm figuring that out right now. Hang on.
number 15 is 0.11.
What?
If the null hypothesis is 0.60, go put your x and your n into your spreadsheet. X38 and 80, null hypothesis of 0.60.
Yeah.
What? Humbug, no way.
Where? But
I,
Those same green boxes.
well, yeah, no, I know. So why is your p-value 0.00?
Well, it was until I changed the null hypothesis.
Oh, okay.
When you pointed out the 0.60, I'm like, oh, yeah, that makes sense.
You do have to change the type of test to less than.
It is less than.
Okay, just making sure.
Yep, no worries.
So wait, on the notes though, I have this big long equation of value minus mean divided by standard deviation.
Yeah, which it would be, except the spreadsheet does it all.
So Lee, what's the test statistic?
That I don't have a clue. That was, like I said, the
Oh.
spreadsheet does not show that.
Wait, are you guys talking about number 15?
Yeah,
Yes.
Why did I get negative 2.282?
I
that's
don't know.
T-score. Which is that the T for this one? Because you know how for the ANOVA F was T?
Oh,
That's true.
didn't finish it then. Okay.
Is Z T for this one?
I don't know. We can try it.
It just says this test statistic. Okay, yeah. So I'm just not done yet. Okay. Yeah. 0.011. You guys are right. Let me finish it.
Well, the p-value is less than 0.06, right? So
No,
always-
the p-value is 0.6.
wait. The p-value was 0.011. Remember? That was 15. 0.011.
15 is the test
no.
statistic.
Crap, I got stuck in the wrong place again.
And the Z is the test statistic, so it is negative 2.282.
Okay, so 15 is negative 2.282.
Mm-hmm.
Yeah.
And then 16 is 0.011.
Yes.
Yeah.
Okay, so 17, since the p-value is less than
We reject.
that, exactly, okay. That's what I was trying to get to. I'm glad you realized I put that in the wrong numbers because I didn't.
Okay, and since we reject, there is sufficient evidence to conclude. We reject the null, so they're not equal to.
Okay, so it's not.
It's either the
They
second or
want to
the
know if
fourth.
it's. I'm sorry?
It's either the
They want to
second
know
or
if the water's decreased. The water quality is decreased. So that's what their assumption is that water quality has gone down.
So
Right?
then it's the second one.
Okay, but okay.
Because
So
what
there's-
Paxton told me last night is if you fail to reject, you will always have insufficient evidence. If you reject, you will always have sufficient evidence. It's just figuring out the last part of the statement.
Okay.
So I think it's the second one.
We can go with that.
If it's wrong, then it's the fourth one.
Alright, alright. I can submit mine first. I just want to make sure. So 7 was 0.11. Let me read off my answers starting with, so 6 was 0.750.
Uh-huh.
7 was 0.11. And then what was 8 and 9? I was just going to...
8 was 0.640.
Sorry, don't say this. Wait, say that one more time.
0.640.
I hate when people start with 0.
Sorry. I've always done it that way. Sorry.
It's alright, it just throws me off. 9 was
0.860.
Thank you, that's so much more. So 10 is decreased, 11 is 20, 12 is 100, 13 is true, 14 is 0.475, 15 is negative 2.282, 16 is 0.011, 17 reject, 18 B.
Yep.
Let me see what I get. 94.74, and we got the last one wrong.
Dang it. It is the last one then.
Yep. Alright. Well,
Okay.
cool. It was really quick tonight. I really thought it was going to take longer based on the notes. I was kind of scared.
Good
Well, once
job,
I
guys.
figured out the spreadsheet, it wasn't too bad.
Yeah.
Makes it much easier.
Yeah, the tutor really helped me last night. I spent like 2.5 hours with him.
Oh,
Cool.
Yeah,
You're gonna have to share the knowledge.
I will.
All right. Well,
cool. Well, you guys have a good night. Thanks a
yeah,
lot.
just so you guys know, next week I am going to be traveling for work. I've got to go to a conference up in Chicago. I should have internet in the evenings, but if not, I'll send you all a text or something to just forewarn you.
All right.
Okay.
Cool. All right. Have a good evening.
Okay, bye.
Bye.
See you guys.